Hey Dragons, this is the Unit 10, Day 1 lesson. You have a handout. I'd like for you to fill out your handout, and whenever you're done you'll have instant notes. So we're going to add and subtract polynomials. What's a polynomial? You have a definition on your handout in practice page. A polynomial is an expression that can have constants or numbers like 4 or -6 or 1/2. You can have variables like x or y or ab, and whole number exponents like 2 and y squared. Can't have negative exponents, but we can have positive exponents or whole number exponents that can be combined using addition, subtraction, multiplication, and division. Well, to make polynomials, these are all polynomials. We're going to come over here and talk about monomials. Mono means one, so it will have one term. Okay, I'll clarify what a term is in here in a second. So we can have numbers, okay, so we can have 5. We can have variables like x. We can have combinations of numbers like -3y. We can have fractions as well. So we can have 1/2 AB to the second power. I got positive exponents, so I'm good on that. Okay. Now, to create what's known as binomials, bi means two terms. Terms are separated by plus and minus signs. So you can think about binomials as taking two monomials and connecting them with a plus or minus sign. So if I take these two monomials and simply connect them with a plus sign, I have now created a two-term polynomial known as a binomial. I could also subtract them, and this would still be a two-term binomial. All right? So I can take -3y and add it to 1/2 ab squared, and this would be a binomial because I have a monomial here and a monomial here connected with a plus sign. So that would be a two-term polynomial known as a binomial. Okay, so trinomials, you might be catching on to this. Like a tricycle, this will have 3 terms. So if I take 3 of the monomials, and I'm just using these as an example, there are an endless number of monomials. If I take the 5 and add the x and then subtract the 3y, notice my 3 monomials connected with plus and minus signs. That would be a 3-term polynomial known as a trinomial. The most common ones that we're going to be working in this unit will look like this. We'll have something raised to the second power, something raised to the first power on the variable, and then a constant or just a plain old number. So again, monomial, 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 but if I connect them with plus or minus signs, I have a trinomial. And I can have a 4-term polynomial. Most of them will look something like this. But we can have a finite number of terms to make any polynomials. So that's what polynomials are real quickly, and we'll be talking more about them later. So let's look at the parts of the quadratic. Okay, standard form. This is the main thing that we're going to be focusing on. We did on our last unit. Hopefully that looks familiar. We have a quadratic term. Remember, terms are separated by plus or minus signs. So I've got 3 terms, 3 monomials connected with plus or minus signs, because you can add, subtracting a negative is addition. So the quadratic term is all of this first monomial. The linear term is this second monomial. And the constant is just the plain old number at the end. The coefficients are the numbers. Coefficients are the numbers. So in this case, my coefficient is going to be the number in front of the x squared. The linear coefficient is going to be the number in front of the x. And the y-intercept is the number at the end that doesn't have a variable visible. Okay? Remember, A, B, and C are numbers. They are numbers. So if we identify the parts of this one right here, my quadratic term, my x squared term, is 5x squared. And immediately I can know the quadratic coefficient. I'm just going to take the number in front of the x squared, which is 5. So my A in this problem is 5 because it's the number in front of the x squared. This is called the quadratic term because it's exactly that. If I were to take just this 5x squared and just graph this, what would I get? I get a parabola, which is our quadratic. Okay? The linear term in this problem is going to be negative 3x. Keep the sign, negative 3x. And so from this, I'm going to grab the negative 3 as my linear coefficient. Why is it called a linear term? Well, if I go back and simply just graph the negative 3x, what do I get? I get a line, linear. That's why that is called a linear term. And my constant is just a number at the end. My y-intercept is going to be 4. So if I plug all of this back in and press the graph button, my parabola is going to cross at 4. So let's get to the adding and subtracting, keeping this in mind as we go along. I'm going to do the examples from your handout, but I'm going to do it a different way. On your handout, they do the problem going horizontally. I'm going to do it differently, vertically. So what I'm going to do is I'm going to look for my quadratic terms. Well, that has an x squared, and that has an x squared. And I'm being able to start this problem because I have a plus sign. Anytime you're adding, in this case a trinomial to another trinomial, but there's an addition sign, I'm happy because I don't have to change anything. Okay? So we're going to take our quadratic terms and we're going to line them up just like we're lining up decimals. Okay? X squares on top of x squares. Okay? Now we're going to look at our linear terms. Now they put these out of order for some reason, but we're going to stay on top of that. Remember, this is how many x's? Yeah, it's a 1x, and this is a positive 3x. So I'm lining those up as well. And then finally my constants. Make sure you keep the signs. Negative 8, positive 2. And now we're going to add the coefficients. We're going to add our a's, b's, and c's. We're not going to add our exponents on this. No, no, no. X squares and x squares make more x squares. Negative 4 plus 2 is a negative 2. X's and more x's, or x's plus more x's are even more x's. So 1 plus 3 is a positive 4 as my linear term. And then my constant negative 8 plus 2 is a negative 6. And hopefully I have the same answer as the handout. Pretty sure I do. Okay? So let's go to the next example. They do the problem, how do they do the problem on the handout? They'll do their horizontally. I'm going to do this one vertically. Okay? So again, I'm looking right here. I go, yay, it's a addition problem, so I don't have to do anything. So I'm looking for like terms. Well, that's x squared, and that's exactly x squared. So 3x squared plus 2 more x squares. Remember, I'm adding just the coefficients, is 5x squared. Now, I look over here, and they're doing xy's, which is a little different. We haven't really seen that, but we're going to go with it. These variables are exactly the same as these. So they are like terms. So 5xy plus, how many is right here? What's the number? Coefficient? Understood, 1. And we're going to add the coefficients. 5 plus 1 is a positive 6 in front of the terms xy. Now these are not like terms because this one doesn't have a y and this one doesn't have an x squared. Like terms have exactly the same variable parts. So this is a binomial final answer. Now, I'll give you one to try on Edpuzzle, and then I'll come back and we'll move on. Alrighty, 3x squared and then a negative 5x squared. For my quadratics, I have a negative 1x. But you notice over here I don't have an x term, so I'm just going to kind of leave that space alone. I'll go to my constant, plus 2, that's a constant, so I'll line this up. So I got a little gap right here, and if that happens, who cares? Here we go. 3 plus a negative 5 is negative 2x squared. Negative 1x plus nothing is a negative 1x. Actually, you could put a 0x here if you wanted to. And then 2 plus a negative 6 is negative 4. Alright, let's get to subtraction. Subtraction is not a smiley face. We got to beware, because subtraction is the same thing as addition of an opposite. Add the opposite. We're going to rewrite subtraction problems as addition problems, because if we have an addition problem, we're just going to add like terms. So fill this in with the. What we're going to do here is we're going to keep the first polynomial as it is written. Do not change the first one. We're going to replace the minus sign with the plus sign. Alright. And then we are going to write the opposite of every term in the polynomial that was behind the minus sign in the original problem. So, here's what I'm talking about really fast. See this first trinomial? This first trinomial is happy as it is. I'm going to do nothing to the first trinomial. The minus sign, I'm going to change that to a plus sign. And then now, the second trinomial, this guy right here, I'm going to change the signs on all of this stuff. So a positive 2x becomes a negative 2x. A plus x squared becomes a minus x squared. And a plus 3 becomes a minus 3. Once I do that, the entire problem is now like the ones that we did previously. So if I add my quadratics right here, that's a 3x squared minus 1x squared is going to give me 2x squared. My linear terms, 2x plus a negative 2x is what? These are opposites, so that adds to 0. They cancel each other out. And now my constants, negative 6 plus a negative 3 is a negative 9. So on that particular problem, we should have simply a quadratic of a binomial of 2x squared minus 9, and that's what's on your handout. Okay, so go ahead and try this one. We'll finish our Edpuzzle with the answer, and we'll go from there. Alright, so I'm going to keep this guy, keep as is. I'm going to do 4x squared plus 5x minus 9. I'm going to change the minus sign to a plus. Okay, and now I'm going to take the opposites of everything, each one of these. So my negative 3x becomes a positive 3x. Now you notice I'm putting it underneath the other linear term. I'm not putting it underneath the quadratic. Got to do like terms. My plus 4x squared becomes a negative 4x squared. And my minus 6 becomes a plus 6. And now we have a happy problem. Alright, these guys right here are opposites, so they wind up being nothing, 0, bye-bye. So 5x plus 3x is 8x, and then a negative 9 plus this is minus 3. So I have a binomial answer.